I want to go through example 11.1 with you and show you another couple of ways to do this problem in case you found that the way Dr. Weil worked it was a little bit confusing. The problem says the mass of a sample of iron pyrite is 1.32 kilograms. What is its volume? The density of iron pyrite is 4.9 grams per milliliter. Now, when you start working this problem, what I usually like to do when I set it up on my paper is to say, okay, what do I know? One thing that I do is, in place of writing out mass and volume and density and writing out the whole word, is I'm going to use abbreviations, the first letter of those, to use the formula and to write down my quantities. So the mass, I'm using an M for mass. Mass is 1.32 kilograms. I'm going to use a D for density, and I know that that's 4.9 grams per milliliter, and I'm being asked what the volume is. Now, the very first thing that you should notice here is that this is in grams and this is in kilograms, and I can't work with those two different units of mass, so I've got to convert them so that they are the same. So that's going to be the first thing that I need to do. So I'm going to take 1.32 kilograms. I'm going to put that over 1. I'm going to convert it to grams because it's going to be much easier to convert this than it is to convert this. So I need to put kilograms on the bottom, grams on the top. That way both my density and my mass will have units of grams. Again, the relationship that you should have memorized is that there is 1 kilogram for every 1,000 grams. And so that's going to give me 1,320 grams for the mass. Okay? Now, there's a couple of different ways that you can do this. I'm going to work the problem twice and show you two different ways, and you can use whatever is easiest for you. Okay? The way that he does it in the book is like this. He knows that density is mass over volume, except when he does it, he writes out all the words. What he wants is volume. So what he's going to do is he's going to rearrange the equation so that he gets the V by itself on one side. So in order to do that, in order to get this V, first of all, you need to get it out of the denominator. So in order to get it out of the denominator, I'm going to multiply both sides by V. So what that's going to give me over here, my V's are going to cancel out, and I'm going to be left with an M on this side, and I'm going to have V times D on this side. If I want the V by itself, since that's what I'm trying to find, volume is going to be mass divided by density. Okay? Now I can say, well, volume is what I want, so volume is the mass is 1,320 grams divided by a density of 4.9 grams per milliliter. My units will cancel out so that my grams cancel. The milliliters is in the denominator, so it's in the denominator twice, which causes it to flip to the numerator. And the volume then is going to be equal to 270 milliliters. Notice as far as significant figures goes, I have 3 here and I have 2 here. Everything I'm doing is multiplication and division, so my final answer needs to have 2 significant figures in it. Now, if it is confusing to you to rearrange equations, so just by using the letters, you don't have to do it that way. You can do the problem this way. So I'm going to go back to my original equation, D equals M over V. I still would have had to put the mass into grams first, but the density is 4.9 grams per milliliter. The mass is 1,320 grams, and the volume is on the bottom. Okay? Now, in order to solve that, if the variable's on the bottom, it's really hard to solve for it down there, so I'm going to multiply both sides by V and get it on the top. So that's going to give me V times 4.9 grams per milliliter equals 1,320 grams, because these volumes will cancel out. Then, if I want to solve for V, I've got to divide both sides by 4.9 grams per milliliter. And then once I've done that, this cancels out over here, so I'm left with V on this side. And I have 1320 divided by 4.9, which gives me 270 milliliters. Okay, you notice that I ended up with the same mathematical process in both cases. I ended up both times with 1320 over 4.9 in both cases. And I ended up with the same answer in both cases. So really it's just a matter of what you find easier. Is it easier for you to take these letters and manipulate them into a form so that you can get the letter that you want by itself? If that's something that is difficult for you, then it's also perfectly fine to take the original equation, plug all of your numbers into it, and then work with that in order to get your answer that way. Either way is fine, so whatever is easiest for you, that's the way you can work the problems.